Hello everyone, you are most welcome to my channel Analytical World. In this channel you will get the basic concept of different analytical instruments that are used in healthcare and pharmaceutical R&D as well as in the quality control laboratory as on daily basis. Please like, share and subscribe my channel to get more updates with me. If you have any question regarding my presentation, you will ask in the comment box. Definitely I will give you the answer. Today I will discuss the most common instruments that are used in the pharmaceutical R&D and QC lab, that is your gas chromatography system. Yes friends, the gas chromatography system. So watch my presentation at the end, and if you have any technical question and the question regarding my presentation, definitely ask in the comment box. I will give you the answer. So let's start. The first slide is showing why would a scientist use GC. GC means your the gas chromatography. Obviously there is a limitation for the gas chromatography if you deal with the volatile components. So in that case you will go for the GC. And if you deal with the semi-volatile components, so you can make it volatile or increase the volatile nature of the components by the derivatization. Your components must be thermally stable and low molecular weight. In that case, scientists will go for the GC analysis. Okay, some components have UV chromophore and volatile in nature. So in that case, better to select GC for analysis of those volatile compounds. And some compounds have no UV chromophore. In that case, definitely they cannot use the HPLC for analysis of those compounds, and there will be no HPLC retention also. So in that case, due to their volatile in nature, they will go for GC analysis. Yes, next slide showing type of samples means which type of components are suitable for gas chromatography analysis. Definitely your component must be organic, thermally stable and able to volatilize. These type of components are suitable for gas chromatography analysis. The discovery of GC, the father of modern gas chromatography, he is a Nobel Prize winner John Porter Martin, who also first developed liquid gas chromatography system. So before we start the engineering part, we should know what is gas chromatography and what is the principle working behind your gas chromatography. So I will discuss one by one. First, what is gas chromatography? It is a technique. It is a analytical tool where by the component of a mixture, that is the sample in the gaseous state are separated as the sample passes over a stationary liquid or solid phase and a gaseous mobile phase. Where the mobile phase is gas is used in case of the gas chromatography. The stationary phase, it may be your liquid or solid. Based on the stationary phase, the GC, that is your gas chromatography, classified into two types. One is the gas solid chromatography. This is also known as GSC, and another is your gas liquid chromatography. This is your GLC. This method depends upon the solubility and boiling point of organic liquid in order to separate them from a mixture. It is both a qualitative and a quantitative tool. Qualitative means to identify the component or actives in your sample, and a quantitative means how much concentration of your active present in the sample you can easily identify it by this tool. Now we will focus the principle of gas chromatography. A gaseous flows under pressure through a heated tube. Heated tube means what? Your column either coated with liquid stationary phase or packed with liquid stationary phase coated on a solid support. The sample is injected using a syringe on the head of column via heated injection port, where it evaporates and condenses. Finally, it is forced into the column by the carrier gas. The mobile phase, which in GC is usually used a helium and nitrogen. The component of the sample mixture interact with stationary phase so that different substances take different time to elute from the column. The separated components pass through a detector. So detector help to burn the components and a electronic signal is generated. There is a electron collectors which collect the electron over time and ultimate the data, digital data sent to the GC software, and a chromatogram is generated of your different components. So here is a schematic diagram of the separation process of the components. There are the three components present in your sample. These three components are separated one by one according to their volatile in nature and polarity and affinity of the components towards your stationary phase. In the gas liquid chromatography, the mobile phase is an unreactive gas such as nitrogen and the helium. Both are used in gas chromatography system as a carrier gas. The liquid phase and the carrier phase showing in this picture. So component detection. What does a chromatogram look like? The chromatogram look like this type. Suppose your sample contain the three components, compound A, compound B and compound C. They are eluted from the column and detected by your detector, and ultimately chromatogram will generate. The chromatogram of compound A, compound B and compound C looks like this. They are separated according to your affinity towards your column and volatile nature and the polarity. So here is this example for you, a sample which contain the eugenol. First we'll run the sample using the gas chromatography system. There will be some peaks is eluted, but we can know what is the peak of eugenol. So first we run a standard. Okay, the standard a peak is coming at 7.01. We know only the peak is for eugenol. So on basis of the standard, we can easily conclude the 7.01, the peak is coming, it is the eugenol peak. The next we will discuss the engineering part of the gas chromatography system, that is your configuration of a GC system. So in general overview, the basic components of the gas chromatography system consist of a regulated and purified carrier gas source. The main function of the gas source which moves the samples through the instrument, and the inlet which also act as a vaporizer for liquid samples, and a column in which the time separation occurs, and a detector which responds to the components as they elute from the column by changing its electrical output. Output means the data interpretation of some sorts. Here is a diagram, schematic diagram for you to easily understand. A carrier gas source with connected with a pressure control. The pressure control is required which provide the constant flow throughout the GC system, and the injection port, the detector, amplifier, a gas oven, and the data acquisition system means the computer and software. So in this slide I am showing the exact picture of the gas chromatographic system. First, I am going to tell you I am not promoting any company's product, only for the educational purpose. I have set up this type of image for better understand what is the gas chromatography looks like. Okay, beside this here is a schematic diagram I have set up. So here is the company's product. Okay, this compressor consists of a auto injector system and the injector ports here, and the sample racks attached with it, and a column compartment and the control panel. So schematic diagram I have set up here. So column compartment, the column is in the column compartment, the column is connected, the one part is connected with the detector and another part is connected with the injection port. The injection port is connected with the gas source, the gas and the gas source and purified gas source, and another ultimate the data connection is connected with the PC system. So here we'll discuss first the gas source. The carrier gas such as helium and nitrogen is used. It must be pure, not less than 99.995%, and contaminant free. Must be contaminants free. If any contaminants present in your gas which may interact with your sample and column also, and create a spurious peak and load the detector and rise the baseline. The function of the carrier gas is to transport the sample through the system. A high purity gas with trap for water, hydrocarbons and oxygen is recommended. Compressed gas cylinders or gas generators supply the gas. Here, for your example, I have attached a schematic diagram of the compressed gas cylinder, which consists of a two-stage regulator, gas regulator, on-off valve, and main tank valve, and hydrocarbon trapper, oxygen trapper. Then it is connected to your chassis. The most important parts of the gas source, all the gas require the pressure and flow control. So it is connected with a pressure regulator and flow controller. Here is a diagram I have attached here to better understanding the blue color, yellow color and the red color panel is here. Gas controller is here. So here the blue color showing for the regulatory setup for the air. The yellow wave setup for nitrogen, and red is high dangerous for the hydrogen. The mobile phase, the carrier gas, must be a inert gas such as nitrogen or helium is used. The function of the carrier gas is to transport the sample vapor to the column, and no chemical interaction with sample main criteria of your carrier gas. So here I have attached some the recommended carrier flow rates for PAT column and capillary column with different diameter and different diameter in internal diameter. Okay, based on the internal diameter. So if you use the PAT column 1.8 inches the internal diameter, if you use the helium as a carrier gas, you could go up to the 30 ml per minute. If you use the nitrogen to 20 ml per minute. If you use the PAT column with 1/4 inches internal diameter, if you use the helium as a carrier gas, you can go up to the 60 ml per minute. For nitrogen, you can go for the 50 ml per minute. So if you use the capillary column 0.05 millimeter internal diameter. If you use the helium, you can go zero point 0.1 to the zero point 0.3 ml per minute. If you use the nitrogen, you can go up to the 0.02 to zero point 0.1 capillary column. If you use with internal diameter zero point 0.1 millimeter, so you can go for helium 0.2 to zero point 0.5. You can go for nitrogen 0.05 to zero point 0.2. If you use the capillary column with zero point 0.2 millimeter id, for helium you can go zero point 0.5 to the 1.2. For nitrogen you can go zero point 0.2 to zero point 0.5. Like this you can adjust according to your internal diameter. The flow rate will be the changed. Okay, this slide showing the main requirements for the carrier gas. The carrier gas must be inertness, suitable for the detector, high purity, easily available, cheap, and should not cause the risk of fire. Should give the best column performance. You can use the uh, hydrogen as a carrier gas for their better thermal conductivity, but main disadvantage, it reacts with unsaturated compounds and it is inflammable. It is very dangerous to handle. So helium and nitrogen we can use. Helium has a excellent thermal conductivity, but it is expensive. For nitrogen, reduce the sensitivity, but it is inexpensive. In many industry and institution, mainly used the nitrogen as a carrier source. Yes, in this slide showing the sampler of the gas chromatography system, there are the two types of sampler used for the gas chromatography. One is the auto sampler system, another is the headspace sampler. The choice of the sampler depends on the analyte matrix. Which type of matrix you are handling. On basis of that, according to your application, you have to select the sampler. So here we'll discuss the most important engineering part of the gas chromatography is the inlet. The inlet introduces the vaporized sample into the carrier gas stream. The most common inlets are injection ports and sampling valves. The purpose of the injector is to introduce the sample into the column by micro syringe. The injector is heated hot enough to vaporize the liquid sample into the gas, and the carrier gas sweeps the sample onto the column. Sometimes we use the glass liner, which isolate the sample from directly onto the column. Injectors are designed for the use with packed column. It is called the packed injectors, and for the capillary column use, it is called the capillary injector or cap injector. Capillary injectors can split a small portion of the sample to place on the column to reduce the sample size, called the splitting injectors. It is the most important part for the capillary injector. Or inject the entire amount onto the column, called the splitless injection. If you use the capillary column, always use split injection system for better resolution and sharpness of your peak. Another most important tool for the GC is your syringe. Okay, when injecting the sample into a GC unit, a micro syringe is used. For liquid sample, where a gas tight syringe is used for the gas samples, the micro syringe looks like this. Here is the back side is the plunger, a part that moves, and the liquid for the liquid sample use the micro syringe. For the gas sample, gas tight syringe is used. Okay, the gas syringe looks like this. So liquid sample approximately 1 to 2 microliter are injected into the gas chromatography, and for gas sample approximate 0.2 to 1 ml is injected into the gas chromatograph system. Yes, in this slide, we will discuss about the headspace sampling system. Beside your auto sampler, another sampling system is the headspace sampling system. The headspace sampling is essentially a separation technique in which the volatile materials are extracted from a heavier sample matrix and injected into a gas chromatograph for analysis. When to use it? When performing a qualitative or a quantitative analysis of the volatiles in difficult sample matrices, when entire samples should not be injected into the GC, when high concentration sample injection is required. In that case, the scientists will prefer the headspace sampling system. So here I have attached a picture of a headspace vial, looks like this. So your sample of interest transfer into this vial, and the vial is sealed with a crimper. Ultim the seal consists of a rubber septa with a aluminium cap. The whole setup is transferred into another base system which provides the heat. The heat will, when you apply the heat in this vial, the volatile part is separated from the non-volatile part. The non-volatile part will remain in the lower sides, and the gaseous volatile molecules will migrate in this space. Ultimately, injection will come down and penetrate the septa and take the sample of interest and ultimate transfer it through a transfer line into the GC system. And after that, whole separation process will take place according to your gas chromatography principle. For example, here I have attached a schematic diagram of a gas chromatography system attached with a headspace sampler. Okay, the headspace sampler connected with a transfer line. Okay, the volatile part will transfer, extracted and transferred to the transfer line and ultimately inject into the gas chromatography system. Okay, through the injection port. We'll discuss the most important part of the gas chromatography is here the column. The next slide showing the details about the column. Yes, the column. The separation happens here. Column is your the heart of gas chromatography system. The most separations are highly temperature dependent. So column is placed in a well controlled oven. The sample vapor is directed into the column by carrier gas compound selectively partition between the stationary phase and the mobile phase. Column is two types used for the GC. One is the packed column, another is your capillary column. First we will discuss about the packed column. So packed column, it is easily understand the column are available a packed manner. The stationary phase for GLC, the polyethylene glycol, esters, amides, hydrocarbon, and polysiloxane are used for the packing material. The packed column tubing, chemically inert, thermally stable, capable of being formed in a coil. For example, copper, stainless steel, glass. Okay, is used to prepare a packed column. Typical column length is your 1 meter to 3 meter. Typical column diameter 1/4 to 1/8 inch. The stationary phase is coated on an inert material to maximize its area and minimize its thickness, and chemically inert and unreactive towards the analytes and the liquid phase. The coated material is then packed into a metal, glass, or tube. The packed column have high sample capacity than your capillary column. Now another column is your most important column used in the gas chromatography in the industry. That is your capillary column. A capillary column is an open tube. Capillary, the both side is open. Okay. Open tube with stationary phase coated on its inside surface. There is no packing. This column ranges from zero point 0.1 to zero point 0.5 millimeter inside diameter. Capillary column provides very narrow peaks. The capillary tubing 30 to 90 meter in length and polyamide coating. This polyamide coating provides strong waterproof barrier. This coating gives the column a brown or black in color. Selecting the right capillary column is critical and depends on the factors such as the selectivity, polarity, and phenyl content. Column diameter influences the efficiency, solute retention, head spacer, and the carrier gas flow rate. Column length affect the solute retention, head pressure, bleeding, and cost. Main disadvantage: more sample cannot be loaded in the capillary column. Here I have attached a picture of a capillary column. So capillary column over packed column. The main advantage and disadvantage of the capillary column over packed column. Okay. And I will give you the example also as a proof which is better for separation. Actually, the capillary column advantage compared to the packed column: high resolution, shorter analysis time, greater sensitivity. Capillary column disadvantage compared to the packed column: smaller sample capacity and it is very costly. Example of some companies column, the Porapack Q. Okay, another example uh, for the capillaries column, DB1, DBWOX and H5, etc. These are the brand name of some capillary column. The column oven. The column oven act as a air bath that carefully controls the temperature of the gas chromatography column. The temperature in the oven can be increased at variable or specific rate. It is called the program temperature, and be held at a fixed temperature is called the isothermal process. The oven can be cooled below 0 degree centigrade to begin the oven program at very low temperature. This phenomenon is known as subambient. The airflow inside the oven is carefully controlled and designed to minimize the temperature gradients around the column surface. So, a brief about the column oven. The isothermal oven. What is isothermal oven? The oven remains at same temperature throughout your analysis. The main advantages: the oven is always ready for your sample analysis. There is no recovery time between analysis. Main disadvantages: because peaks broaden with time. Okay, late peak may be difficult to detect or measure. Samples with wide range of components take a long time to run. Slide, I'm showing the column oven temperature. Actually, the main difference between the isothermal process and the program temperature. Here is a set up a program temperature and isothermal process. The isothermal process, the column oven temperature is at 150 degrees centigrade and the injection temperature 120 degrees centigrade, and diluent type use the water, and flow temperature 1 ml per minute. The carrier gas nitrogen. Total run time 10 minutes. Okay, it is the isothermal process because the throughout the 10 minutes the temperature is remain same, means the column movement temperature 150 degrees centigrade. So this type of ethanol peak is coming. So I have transferred it into a program temperature. Program means and serially it has been increased the temperature. So here is the oven temperature. First I have started with the 50 degree centigrade, hold for 5 minutes, then 35 degree centigrade per minute, 125 up to the 125 degree centigrade, hold for zero point 0.5 minutes, and 30 degrees centigrade to 20 degree, hold for zero point 0.5 minutes. This is called your the program temperature. And the peak is, I'm getting a very sharp narrow peak, and it is this peak is accepted. Okay, this type of broad shoulder peak is not accepted. Yes, the another most important part of the gas chromatography system is your the detector. Actually, there are so many detectors are available. Mainly the industry use these four types of detectors. Okay, the FID, TCT, ECT, and NPT. FID means the flame ionization detector, and TCT is your the thermal conductivity detector, and ECT is the electron capture detector, or NPT is your the nitrogen phosphorus detector. The detector must be optimized for the sensitivity, linearity, and stability. Detection limit I have given. This is approximation. The actual value will vary depending on the compound structure and analytical conditions. Here the flame ionization detector, the detectable compound, organic compounds other than the formaldehyde and the formic acid. The detection limit is zero point 0.1 ppm. The thermal conductivity detector, this is also known as the universal detector. All compounds other than the carrier gas you can detect using this detector. The detection limit is 10 ppm. The electron capture detector, that is your ECD, the organic halogen compounds and organic metal compounds is detectable in this detector, and the detection limit is zero point 0.1 ppb. And another most important detector, this is your the nitrogen phosphorus detector. The organic nitrogen compounds, inorganic or organic phosphorus compounds is detected in this using this detector. The detection limit is zero point 0.1 ppb. Yeah, first we'll discuss about flame ionization detector, that is your FID. And the schematic diagram of FID I have attached with my slide. The FID is the most common detector used in gas chromatography. The FID is sensitive to and capable of detecting compounds that contain carbon atoms, which accounts for almost all organic compounds. The FID creates a hydrogen flame by burning air and hydrogen supplied from the below in the picture. The carbon in the sample carried into the detector on carrier gas is oxidized by hydrogen flame, which causes the ionization reaction. The ions formed are attracted by collector electrode to an electrostatic field, which I have mentioned in the picture, where the components are detected. The selectivity of the FID compounds with carbon-hydrogen bonds are most selective for FID. Gases, the combustion gas hydrogen and air are used for the combustion of the flame, and makeup gas use helium or nitrogen. You can use the temperature 250 degrees centigrade to 300 degrees centigrade to burn your components. So now we'll discuss most important detector, the thermal conductivity detector, that is your the TCT. TCT is also known as the universal detector. The TCT can detect all compounds other than the carrier gases. The TCT is mainly used to detect inorganic gas and components that the FID is not sensitive to. Helium is used as a carrier gas. If you want to analyze the helium and hydrogen, you have to use nitrogen and argon as a carrier gas. The main application for the formaldehyde, formic acid, carbon monoxide, and carbon dioxide. Estimation: the analysis of compounds not detectable by the FID. Here I have attached a schematic diagram of the TCG detector. A direct voltage is applied between A and B when only the carrier gas is flowing at a constant flow rate. Each filament maintains a constant temperature and a constant voltage is produced between C and D. The components are eluted from an analysis side column. A change in the filament temperature occurs, which changes the resistance value and changes the voltage between C and D. The TCD detects target components by reading the change in filament temperature caused by the difference in thermal conductivity between the carrier gas and the target components. So now we'll discuss another most important detector, that is your ECD. So I have attached a schematic diagram of ECD in my PPT. The ECD is a selective high sensitivity detector for electrophilic compounds. The ECD is capable of detecting organic halogen compounds like fluorine, chlorine, bromine, organic metal compounds like the silicon, etc. Because the ECD is fitted with a radioactive isotope. In India, if you want to install ECD in your laboratory, you require a permission and notice from Bhabha Atomic Research Center. The main application of ECD: environmental analysis, residual chlorinated pesticides, and residual PCBs, chlorinated VOCs in discharge water, environmental organic mercury. The ECD detects ion by reading the change in voltage value that maintains a constant ion current gathered at the collector. Nitrogen, which is used as a carrier gas for ECD, is ionized by the beta waves, is emitted from 63 Ni radiation source. So at the end, the last detector we'll discuss about the nitrogen phosphorus detector. It is also known as the NPD. The NPD is a selective high sensitivity detector for organic nitrogen compounds, inorganic and organic phosphorus compounds also. The NPD does not react to inorganic nitrogen compounds. The main application in drug analysis of nitrogen and phosphorus pesticides. The NPT detect ion by reading the change in ion current gathered at the collector. When a current is passed through the platinum coil with an alkali source attached to the coil, mainly the rubidium salt is used. The coil increases in temperature, which creates a plasma around the alkali source. Rubidium radicals are, are generated within this plasma, capable of oxidizing CN and organic phosphorus compounds. So friends, we have already reached at the end of our presentation, where last we'll discuss where is the gas chromatography mainly used. Medicine, pharmaceutical industry, means the chemical industry, environmental, petrochemical, food and flavors. Medicine detect the drugs in blood and urine. The pharmaceutical, the drug testing and quality control. The chemical detection and analysis of the chemicals. Research and quality control. Environmental analysis of air, water and soil for pollutants. Petrochemical industry analysis of gasoline, oil, natural gas, and petroleum products. In your food and flavors, the quality control in breweries, distilleries, and flavor and fragrance labs. Thank you. So, we have already reached at the end of our presentation. So if you have any queries regarding the gas chromatography system about my presentation, you can write in the comment box. I will give you the answer. So next video, I will come with the different type of troubleshooting and question answer section regarding the gas chromatography. Please stay tuned with me to get more updates about the analytical system that are used in the pharmaceutical industry. So thank you. Bye.